go. Hang on. Give me 1 more second. I'm trying to punch it. I would talk really fast, so I won't go over. Or am I already over? Yeah? We'll see. We'll just, go ahead. You can go ahead. You can go ahead. You want to talk?
Hey, everyone. Hello. Hey, that's fine.
I can introduce myself.
Back, everyone.
So, welcome back. And this is Jerry. We'll be doing a practice.
Hey, it's actually me this time. All right. So if you are here for a different talk, you're in the wrong place. So let me check on time. Okay. So first, this is the x86 fast reboot and panic fast reboot project. So I'll first give you a little bit background and what exactly we're trying to do. And since this is a technical crowd, I'll give you a lot of technical details, probably more than you want to hear. Stop me if I do. And like they say, a demo is worth 1,000 words. I'll give you a demo, and hopefully, it's a lot more interesting than the presentation, than the slides themselves. And then I'll, if time allows, I'll go, I'll talk about summarize the whole speech, of course. And if time allows, I'll go into some advanced features that kernel developers might be interested in. So how many of you here actually are system administrators? And how many are developers of modules that cannot be unloaded? Nobody? So even though not every road leads to reboot, a lot of them do, like system administrators, when after they have applied a patch, or for developers, especially those kernel developers, that typically which file do you modify if you're a kernel developer? Gen Unix, Gen Unix, and those cannot be unloaded clearly. And how do you test it? You copy the binary to the target system, and then you reboot the system. So like I said, even though not all roads lead to reboot, a lot of them do. Unlike my, so it was when I first got this working, I was so excited. I went to my office neighbor by the name of Phil Edge. He's actually the manager for the power management team. I said, Phil, look at this. This is amazing. And then he was like, I work on the Sunray. I never reboot my system. So I was like, oh, I guess it's not particularly interesting to an audience like that. So if you have to reboot, how long does it take? For those of you who follow the Sun product line, you recognize that those are some of the currently shipping x86 platforms. And I also put a code name there if you're from Sun and you don't follow those numbers. As you can see, with the various numbers of CPUs and memory, the reboot time is, takes about 2 to 3 minutes. Doesn't seem like a whole lot of time, but when you type reboot, typically what do? We typically just get up and go get a cup of coffee. And if you ever wonder why kernel developers often come jittery, because we reboot the system a lot and we ended up drinking a lot of coffee. And also for a person who is impatient like me, that's just way too long. It's like a watched system, a watch pot doesn't boil, a watch system takes forever to boot. So to everybody, to us, boot time and reboot time is like downtime. If you're a Wall Street customer, it's not processing any of the trade information. If you are a web server, a server, it's not servicing any webs. But in general, it's just like it's just bad, the downtime. And also for me, it's the quality of life. I would rather not grow old watching the screen refresh, day in, day out. So, all kinds of good reasons. So now that we are fully motivated, at least I am fully motivated, is it possible? So to answer that question, we need to understand what exactly is involved when you reboot the system. So the top is x86 and the bottom is Spark, so that you can have, for those Spark users, you can clearly compare the two. And so when you type reboot, eventually it calls this routine calls like PC reset. It resets the hardware, puts the hardware into this good known init state. And then it jumps through the reset vector to, on x86 it will be BIOS, on Spark it will be the post. The firmware BIOS and post in this case does two main things, has two main functionalities. Number one, it tests components such as the processor, memory, all the peripherals necessary to boot. And the second is device probing, so that it can find what all the what the system has, right? So once it's happy with the state of the system, it would load grub into memory, pass control to grub, and what grub and on Spark OBP do is that it would load the kernel and boot archive into memory and then pass control to the kernel. So it would seem that if the operating system, Solaris in this case, can do some of those steps, we can short circuit those reboot steps and make it go faster. So is it possible? So let's take the first, angry red. I used the red, not good. So hardware reset. Why is it necessary to put the hardware into this good known init state? Mainly because that's what the BIOS can configure from. The BIOS cannot start from any random spot. My son, who is sitting in the back, he's a wonderful piano player. He's learning to play. He can actually sing, sing along. He's playing the Scarborough Fair. But if you ever interrupt him in the middle, he will have to start all over again. So he's doing this, and then so because his mind has been programmed to always start from this good known init state. So if you interrupt him, it's difficult for him to resume. However, Solaris is not an 8-year-old boy who is just learning to play. Solaris is like this master, like Mozart if he gets to live to 70. So we can surely configure devices from not just that one good known init state. At least that's what I would like to believe. I looked at a lot of the device drivers. Actually, in their attached routine, the first thing they do is that I'm not even going to trust what you say you are in. I'm going to reset you. And I would actually like to see the device drivers all do that. So let's keep that in mind. If you have any questions, you can keep that in mind. So that's feasible. So the next thing is BIOS. As I mentioned, it does two things, testing components and probing devices. We already know that Solaris can probe devices. That's how Hotpot works. We have that capability in place. So how about testing? Is it safe to skip all the testing? Is Gavin still here? Maybe he's not anymore. Oh, he is back there. So as Gavin have told you, components don't just fail when you're testing it. Well, just because you have the check of 5 years ago, and doesn't mean that you won't have the risk of dying of a heart attack. So many of you must have noticed by now that components fail at pretty much any time. That's why Sun has developed this wonderful FMA framework to catch such transient failures, new failures, and isolate them, not only detect them, isolate them, and offline the components. So Solaris is this wonderful, wonderful capability that the Fast Reboot project totally relies on. I relied on FMA to be able to catch this kind of transient faults and stuff and offline the faulty components. So with that in mind, it seems that the operating system can sort of do what the BIOS does. How about the next thing, grub? All it does is to load the kernel. Solaris is the fully operating system with support of any file systems. So pretty much any. Surely we can read a file into memory. So to me, it seems it's possible. What do you guys think? Not so convinced. So this is just recapping what I've said, with all those technologies possible. So now I went to my boss and say, hey, that's really cool. I want to do this project. And then my boss was like, well, what exactly are you trying to do? Just put it in a simple sentence for me so that I can measure you against later, Just like signing a contract. So that's why I said a few seconds. I dare not say 5 or 8, just in case later he would say, hey, you say 5, and now it took 6. So to put it into a very simple sentence, I would like to be able to bypass the red box, the hardware reset, and BIOS, and replace those components with an in-kernel bootloader so that when you type reboot, it can immediately go back to the kernel. And so from rebooting ... to the source banner in a few seconds. So is it possible? We have already seen the block diagrams of all the software components that's involved in fast reboot, in a reboot process. So how does that look in the software block diagram? So first you type reboot or x86 for those good customers who actually do what we told them. And then those commands would go through the libraries, use UMN, which is the system call, get into the kernel. So the light blue is the userland, green is the kernel. So once you're in the kernel, you kill everything, you sync the file system and mount it, and you call this machine dependent. AMD stands for machine dependent boot code, which pulls the reset line. That's what the result put the system into the hardware reset state. So this is the traditional reboot flow control. So what would it look like for fast reboot? So as you can imagine, the commands will have to be changed a little bit so that you can process, at least you want to do a fast reboot. And so that's quite straightforward. So all the purple blocks, okay, let me stop right here. This is the single most important slide of this whole presentation. And I will ask you a question at the end. I have a limited edition San Francisco t-shirt to whoever that can answer that question. So really pay attention. The reason this slide is so important is that once you understand all these, how they work together, what they represent, the code is just code. It's really easy to read, really easy to follow. Like data structures, they would all mean something. But you do need to understand the flow, how one piece has control to the next. So now I can restart. So first, some userland changes to process the options. The second one is now that I no longer have grub to load the kernel, I will need a fast boot load kernel component to actually read the kernel and boot archives into memory. And the next thing is that since now I'm bypassing this reset, pulling the reset and putting all the devices into this known init state, I will have to call device quiescent, put all the devices into such a state that they can be configured by their drivers attached routine. I'll go into more detail why that sounds so convoluted, but I'll explain to you later. And then when all that is done, it will go to the fast boot switch and hand control to the next kernel. So 4 things: the userland code to process the options, the in-kernel bootloader, device quiescent, and the fast reboot switcher to pass control to the next kernel. So 4 things. I'll be going through. At the end, you're going to be seeing. You're going to see this diagram over and over again. So at the end, you're going to see like flashing purple or something. This is to recap what I have just said. So first, we'll talk about the userland part. How many ways do you need to reboot the system? We have many. And just in case that you don't like rebooting x86 or UMN, you can write your own. So, to take your own special arguments. Oh, well, since I'm rebooting, I'm not going to shut it down and halt. And oh, I always press the wrong one. So when you type reboot, how do I know? How do I know whether or not I should fast reboot the system? So this is new as of March. For those of you who follow Nevada bills, this is actually in Bill 112. So what I did is I introduced a service called boot config service. So inside there's a property group called config, and in there are two properties. One is called fast reboot default, and the other is fast reboot on panic. So as at the time of integration, they are both enabled by default, which means that you just need to type reboot, and the system will fast reboot. What if I don't like it? As soon as I put back, one of my friends by the name of Mike Sullivan immediately came down to my office and said, "Hey, Sherry, I typed reboot, and I was ready to go get coffee, and it came right back up." And I was like, "Isn't it great? Isn't it great? It's so fast. That's exactly what I wanted to do." And he said, "No, I want to go get coffee." So I went to his office, and I was like, "Okay, this is how you turn it off." But so giving people this option is really critical, I think, so that they can't just come and complain about it and say, if you don't like it, just turn it off. But I think he secretly loves it. I bet as soon as I left his office, he turned it back on. So that's how you can change the default config. So with that enabled by default, how do you fast reboot? All you need to do is to reboot. Yes? Yeah. It will definitely immediately fall back. So the panic, so there's a feature called fast reboot on panic. I'm going to cover that in the advanced topic if I have time. That is enabled, that particular service has dependencies on multi-user for the very purpose of avoiding panic reboot loops, But sometimes if you're very unlucky, if you're developing something that gets loaded after multi-user, and you didn't boot to single user when you're doing development, so it's possible to get into that, panic loop state. But in general, if it panics before it gets to multi-user, yeah. 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 So I just use James. Yes. Okay. If you do want to, if you're developing something that will, I can teach you how to use it to your advantage. It's very cool. That's how I debug my device drivers. But you need to keep an open mind. You cannot just say, I don't like it, and then it makes it really hard for me to show you all the cool tricks. If you're just going to come to tell me how I hate it, so just turn it off then. I don't want to hear about it. So a new feature that we introduced in 1.12 that I'm really, really proud of, and I think that you will all love, is you can now say reboot to a number. So I don't know, probably not many of you actually use that particular feature. Today you can actually use ADM list menu and see all the menu items that you can reboot to, and you can type reboot, say 5, to the 5th menu item. Now that is tied in with fast reboot. So you can actually say, boot ADM list menu, and you can say, my first boot environment, second boot environment, I want to boot to my 7th boot environment. You can just do reboot 7, fast reboot to it just like that. It's really cool. And that's actually how we share test machines. For example, we have this one Nehalem test machine for all of us in the core kernel group at the very beginning. So all of us will have our own boot environment, and whenever you get onto the system, you just reboot to yours. It is very, very convenient. And for that reason, everybody is willing to sync with MyGate, even during development, so that they can have that feature. And I really enjoyed it too, because that way I get a lot more testing. Yes? Which, you can do boot ADM if you have, say, reboot to 5, that kind of stuff. You can just do boot ADM list menu. It will tell you which one is the default. Because when you type that, it changes the default to that particular menu entry. It is very handy. I really like it. And if you're a kernel developer like me, you might want to boot with a gazillion other options. For example, you might want to drop into KMDB and see all the boot messages. You might want to boot to your own kernel, like the second one. You might want to boot to a different boot environment by just specifying the ZFS dataset name. Or if you use the UFS, you can say reboot to that disk. And you can actually even mount it, just mount whichever boot disk, and then explicitly say, reboot to that. So it's very handy. I encourage you to play with it. And if you use live upgrade, if you have a different boot environment, you can also say reboot-E to that particular boot environment. And that last feature is not available in Open Solaris yet, because in Open Solaris we have a new way of processing boot environments. But that's all gonna sort itself out soon enough. So, but all this information is on the Open Solaris webpage. It's also on the Nehalem Open Solaris blueprint that is referred to by Max slide. So there are also other ways. We tell our customers to use x86 because x86 also shuts down all the services. So if you're running Oracle, you can, when you type x86, it will shut down, shut it down safely, theoretically. So you just need to type x86 and it will fast reboot. And you can also do UMN 2.8, but that does not check to see whether or not your boot archive is up to date. So if you're a really experienced user, really comfortable with all the recovery, you can do that. But otherwise, I would suggest use Reboot because that would check whether or not your boot archive is up to date, and if it's necessary to build it, it will rebuild it. So we have just covered the userland part. So now, once again, userland, the in kernel bootloader, device present, and the fast reboot switcher. So now we're moving on to the next one. The in kernel bootloader. Lots and lots and lots of words, but it will become really clear when you look at this picture. So I don't want to bore you with all those. So it becomes really clear once you look at this picture. So first, it needs to process the argument that has been passed down through the userland code to figure out what root disk or data set that you want to reboot to. So once it has that information, it will read the kernel and new boot archive and the fast reboot switcher into memory. As you can see, they are scattered everywhere in high memory. What I mean by high memory. So eventually, I would like the kernel and the boot archive to be where grub would have loaded it, which is in low memory, so that the entry to the kernel would be the same regardless of whether you have come from grub or come from the kernel. So that's just for simplification, and it's very easy. It's a lot easier to debug if you have one fewer variables. So eventually, I want to relocate them to where grub would have loaded it, which means that if I use a really simple copy routine, I don't want to, when I'm loading them into memory, I don't want to load them to low memory, so that when I'm doing the copying, I will overwrite myself. So that's just for simplification. I'm sure there are many ways that you can make it so that you can pretty much bring in the new kernel to any spot, but currently that's not how it's done. So that's done by the kernel bootloader. Once it has done, once it read it in, it also needs to build a list of all the physical pages representing the new kernel and the boot archive, because you need to be able to find them later to relocate them. And in order to do that, I also have to build a page table so that I can actually copy them later. And what does that mean? So this is a data structure that represents, say, the kernel. Lots of words. You can, if you're interested, you can look at that later. What does it look like in the kernel? So you can actually drop into KMDB and you can dump it out. If you look at the PT, so the PT list is where all the physical address of all the pages. So if you just dump it out, it just looks like the physical pages. And those of you who are familiar with page translation entries, it can tell you that's a large page, referenced, and valid. But this is not text. In the page table, yeah, I think this is a lot of detail that you can obtain later from reading code. But let me show you what it looks like in this picture. So for 32-bit kernel, you'll have 3 levels: the page directory pointer table and the page directory table. And if you have if you're not a large page, you will also have a page table. So that's how you get to all your pages. So this is a page translation table that I have to build to keep track of all my pages. What does it look like for 64-bit? You just have one more level. So it's not that difficult. So now here's a good question for you. If I have 32 meg, if my combined size of the board archive and the kernel is 32 meg, how many page tables? I'll call that, one is a page table. How many of those tables do I need to allocate so that I can get to all my pages later? You guys can keep thinking about that. That might be the question for the draw. So let me repeat that question. If I have 32 meg full combined full archive in the kernel, how many page tables do I need so that I can get to all of them later? Yes, he already has an answer. 16? That's very good. So, but not yet. So keep thinking. Very good, but we can do better. We don't have 4 meg pages. It's 2 meg pages on Intel. So you can get to 1 gig. You can get to 1 gig if you use large pages. So like that bottom one, you can map 1 gig. So fast boot, we just cover that in kernel bootloader. All it does is to read from the target disk or data set into memory and prepare all the page tables and physical memory lists and such, so that later we can copy them and relocate them. So next thing is device pricing. This is actually very interesting, if I have time to tell that story. I stole this slide. I don't know, I didn't stay for the DDI talk yesterday. I don't know if they have a slide looks exactly like this. I stole this from Seth Goldberg, who was doing a TOI on device drivers. So for those of you who develop device drivers, you recognize all this DevOps and CDOps, etc. So QuiES is just an additional DevOps. Actually, I have Garrett Demore here to thank. He was the one that convinced me that I should have my very own QuiES device op interface. So he's the person you have to thank for making this possible. So what exactly does the device pricing do? As we said, we are no longer putting the device into this known init state. So what exactly do we need it to be in? So we need the device to stop doing DMA and stop generating interrupts. But you don't have to leave it at exactly the same state as where the BIOS would have left it, as long as I meant the device driver's attach routine can successfully configure it from that state. So it's a much more relaxed requirement. You can actually put it in whatever state you want. However, you must be able to configure it back from that state. So it's a very clear and relaxed requirement, and I hope that makes the implementation much easier. Yeah, one time I actually implemented a bunch of them for the NICs. And then I was trying to convince Sean Martin, who is our NVIDIA person, to implement it for NVIDIA. And then he said, that's impossible. I said, well, I'm not even a driver person, and I did it for even 1000G. Surely you can do it. He said, I'm not even a computer science person. He's a physicist, apparently. So I said, okay, you win. But eventually he did implement it for me, and I'm really grateful. So that sounds really simple. Yeah, any questions? So the next thing, now that we know exactly which kernel we want to reboot to, we loaded, the new kernel is in memory, all the devices are quiet, and we know how to configure them from that state. What's the final step? The fast reboot switcher. So once again, lots of words, but it becomes really clear when you look at the picture. All it does is to relocate the new boot archive and the new kernel to where Grub would have loaded it. And then it jumps to the fast reboot switcher. So of course, that sounds really simple, but it has to use all those data structures that we have prepared using the internal bootloader. So Now that now that I have shut everything down, what happens if I have a bug in my fast reboot switcher? How do you debug it? So dtrace clearly is not going to be able to help me, so I invented dtrace. Have you guys ever seen a D before? So in my office, I have systems laying everywhere, and they have their panels open because this is an Ultra 40. It has an LED that I can actually send LB port 80 with different values so that I can actually tell where the system has died. So that's how to debug your fast reboot switcher. The debug code is actually the if def is still there, actually. So, demo. I hope this is exciting. I'm not rude. Yeah, James is gonna go. So this is actually booted to my bits. So I hope my bits work. I haven't tested it. I did it last night, 14. So right now I have booted to ZFS BE3, which is running my bits. So what if I want to say reboot to ZFS BE2? I should have double checked. But if it doesn't work, it's because I just DFU'd it yesterday. Was it yesterday, the 14th? See, there it's back. I don't know if you guys are following. That's not bad. It's really funny, actually. The first time I demoed this to Mike Shapiro, and then I said, watch, and I typed reboot, and it came back. He said, no way, you just wrote a shell script to print the banner. So, like, did I deliver on my contract? Yes. Where did I slideshow? Yeah. See, before I was running my bits, now it's running 119. So I'm not faking. To the prompt? Oh. That part, see, now that I have cut out the BIOS part, there's no excuse for us not to improve from banner to login anymore. So that's why I've been trying to not recruit, but try to convince people that now is really the time to try to shorten the time from banner to login prompt. Yeah. So how fast is it? So the red one is the regular reboot time, and the fast reboot. See, thank God I say a few seconds. But this seems a little bit longer than what you have observed from like actually seeing the rebooting to the banner. Because I have my test person, I don't want to put my test person, because I'm supporting like, 32 platforms, right? I don't want him to have to hold a stopwatch and go, okay, hit return, and go to. So I told him, I said, okay, just measure the time when it's logged in VAR-ADM messages. So, he can actually write a script to put them in a reboot loop and then grab all the reboot numbers. So that's why it says it's measured from rebooting to solar spectrum being logged in VAR-ADM messages. So it's slightly longer than the user experience. So I think I deliver on that promise, but to boot? Oh, the 10 seconds? Because that particular system is on flash. And for some reason, it takes a long time to log it. And that's also a prototype box that we did a measurement on. But compared to 3 minutes and 2 seconds, I'll take 10 seconds any day. Yeah. So panic fast reboot. I know Garrett's dying to talk to me. That's why I'm going to escape as soon as I'm done, you know. And I'll just tell him, Garrett, just turn it off if you don't like it. But panic fast reboot is really good for us when we were developing certain drivers, because by default, this is how to use it for developers. You know, if you're a customer, hopefully, you know, number one, I hope the panic situation is really rare, and when it panics, it quickly comes back, because that kernel has been up and running for a long time. But for developers, you pretty much panic the system, you know, all day. The really good trick is that always boot to single user. You know, have the boot line to be single user, because that way, if it panics once it gets to multi-user and loaded your driver, it will go back to single user. And then you can configure the network and copy your newly, you know, compiled driver or fixed driver onto the system, update the boot archive, and then do that again. If it panics the system, you still have the good, you know, boot archive without your broken driver, and you can go back to single user again and, you know, repeat the same exercise. And that's actually really fast in debugging drivers. And that's also how I found a lot of the Xorg, what's that called? Xorg, they all have this binary graphics driver. You know, when we get new ones, it tends to panic the system quite often. So I actually used that to debug it, and it was very, very fast. But when can it work? What if your bug is in the crosscall code? Because I actually need to use the crosscall if the panic CPU is not the boot CPU. So if you are like, for example, our friend Joe Bonacera, who is, you know, actually breaks and fixes this crosscall code all the time. I told him, I said, Joe, just for your benefit and my benefit, my sanity, just turn it off, because you are actually causing, you are panicking in the crosscall code itself. It's, you know, impossible to recover from. But that should only be a case for very few developers who are actually touching those codes. And also, what if it's machine check error that FMA cannot or doesn't want to handle, or FMA deems unsafe to do fast reboot? So actually, Gavin and I and his team, we are actually talking with each other. I would need to give them an interface saying that for this type of fault, it's simply not safe, because being FMA, cannot offline all these components, so that it's safer to just go through BIOS. Hopefully BIOS can catch it and offline whatever component. So that is still in the works. There's a lot of, you know, new things that are coming up. We're trying to make this a better experience and more safe, so safer for everybody.
What about
Cluster fencing. What's the fencing panic? Okay.
For example, one node can't do the shared storage anymore.
I see.
Then it's allowed for panic to
Okay.
fence it, and hopefully this cluster will
Okay.
will cost users or
It should, yeah, it should. Fail fast. I have never tested it in the cluster mode. If it's anything beyond just loading a boot archive and jumping to it, and then fast reboot might not be able to handle it. But I have never tested with cluster. So yeah, probably there are. I'm quite sure if there's cluster, there are a lot of drivers that doesn't support fast reboot. Yes. That's correct. Yeah. 2 minutes. I only have 2 minutes, but I would be happy to answer any more questions after that. So, life made easy. You know, as I said, debug early boot problems. Anonymous tracing. Well, that's another one that I really like. Those of you who do anonymous tracing, what do you need to do once you have, say, enabled anonymous tracing? You have to reboot. Now it's trivial. You just type reboot, it comes back. You get whatever traces you want. If that's not the one you want, you change your script and do it all over again. It's really, really convenient. So Here are all the documentations. It's also on opensource.org. If you go to Intel platforms, there's a little sidebar on the bottom that says Fast Reboot, has all the documentations, all the man pages, all the techniques, the gotchas. So, and also in my blog, I try to put a so-called FYI in my blog so that people can refer to it and figure out how to use it. So that concludes my talk. Thank you very much. I'll take my laptop, yeah? You want to? Oh, thank you. Here's my chocolate. Oh, pause. My question is, what are the 4 components in the Fast Reboot, 4 software components in the Fast Reboot project? Anybody? Raise your hand, raise your hand. Okay, yes. What do you mean by kernel rebooter? Okay, the internal bootloader. Okay, so you got it right. For the bonus of one of the super cool, squishy open source balls. What does fillaball mean? What? No, it actually means dead river. So you don't get that. Oh, but you do get the beautiful limited editions and the subscription.
Do I need to put myself on the microphone? I mean,
Yeah, what happened to that?
I guess it's this one.
This is the mic that we use to record.